Hi there, my name is Mr. Chick and I'm here to tell you about forces and motion. This video has been designed to help students understand about both forces and motion and how they are related. I have a sequence of videos here that covers forces, motion, momentum, work, and energy. First thing we'll look at is motion. Let's start off with speed. Speed is how fast something is moving. Instantaneous speed is how fast something is moving at any instant in time. If you are traveling at the same speed, you are traveling at a constant speed. We'll look at average speed. The average speed is calculated from the time it has taken something to travel a distance. This is different from instantaneous speed because it is an average over time. It is calculated using the formula speed equals distance over time. The average speed is the distance travelled divided by the time taken. The standard unit of speed is meters per second, or we write this as m/s. This is because the distance is measured in meters and the time is measured in seconds. Therefore, we have meters divided by seconds, or meters per second. However, speed can be measured in kilometers per hour, miles per hour, kilometers per second, or any other method. Velocity. Velocity is speed, but with direction. This means the units of velocity are also meters per second. The difference means that you can have a negative velocity. You can't have a negative speed, but a negative velocity means it's going backwards. Have a look at displacement now. The total distance travelled is the distance travelled. We measure distance in meters. Displacement is also measured in meters. However, displacement is how far away you are from where you've started. So have a look at this diagram here. You can see the displacement is a straight line from the start to the end point, which is clearly much shorter than the actual route taken. Acceleration. Acceleration is not just speeding up, but also slowing down. We tend to say that slowing down is called deceleration, but really it is just negative acceleration. This is because it is the change in velocity or speed over time. This can be calculated using the formula acceleration equals change in speed over time. The units for acceleration are meters per second, or in other words, meters per second squared. This is because it is the speed, which is meters per second, divided by time, which is seconds, so we get meters per second, or we just write this as meters per second squared. If you slow down, your acceleration will be negative, hence it is called negative acceleration. Okay, let's have a look at some motions now of some different cars. Here we have three cars that are moving. The red car accelerates and then decelerates. The green car is traveling at a constant speed because its speed is not changing. The blue car has a constant acceleration, but its increase in speed is constant. Let's have a look at these graphs now. Here we have two cars moving. Both cars travel at a constant speed, but the red car is much faster than the blue. Therefore, we can see that the red car covers a greater distance in a shorter amount of time. Graph is a distance time graph because it displays distance and time. The speed can be calculated by dividing the distance travelled by the time it has taken. We'll have a look at constant speed on graphs now. Here we have three graphs that have the motion of a blue dot plotted. On the distance time graph, there is a straight diagonal line. This means that the dot is moving at a constant speed. On a speed time or velocity time graph, this is shown as a horizontal line. This is also seen on the acceleration time graph, but is zero, as there is no acceleration. Again, we have the three graphs that have the motion of a blue plot. On the distance time graph, there is an upward curve. This means that the dot is moving at an increasing speed, it's accelerating. On a speed time or velocity time graph, this is shown as a diagonal line. On the acceleration time graph, this is seen as a horizontal line because the acceleration is constant. Right, here I've cycled to school. So this is an example. You can see that at the point between the time of 1 and 2 hours, that length of time is 1 hour. The distance I have travelled is from 15 to 20 kilometers. So the difference there is 5 kilometers. I can calculate my speed by dividing the distance by the time. That is how you calculate the average speed. So we can use the graph in order to calculate that. And in this example, the answer is 5 kilometers per hour. Here's another example. I flew somewhere this morning. What does the graph show? How far did I travel in 3,000 seconds? And what can we calculate using distance and time from the graph? First of all, it shows a constant speed because there's a diagonal line. If you look at the plot, it is 90 kilometers. And the final thing is we can calculate speed, as we just mentioned. It's distance divided by time. Here's another one. A rat ran through an alleyway looking for some cheese. What is the rat's motion at the bottom of the graph? What is the motion of the rat on the first curve going up? And what is the motion of the rat when the graph is flat? Well, first of all, the bottom of the graph has got a constant speed because it's distance and time and it's a diagonal straight line, constant speed. On the first curve, it must be accelerating because it's going through a greater distance in a shorter amount of time. When it's flat, the graph is flat, the distance is not changing but the time is. So obviously the rat is stationary, it's not going anywhere. Here's another one. These graphs both show a ball being thrown up into the air. What happens to the ball after 1 second? Why does the ball go to 10 meters on the left graph but back to 0 meters on the right? So what does displacement mean? Right. First thing, after 1 second, the ball stops in midair. On the left graph, it shows the distance travelled, the total distance travelled. On the right, it's showing the displacement. So, what does displacement mean? It's the distance from the start position. The total displacement is 0 because the ball has been thrown up and it's fallen to exactly the same spot. Distance travelled, it's gone up 5 meters and then it's come another 5 meters back down, which is 10 meters. A cyclist cycles to school. What is the speed of the cyclist during the first second? What is the motion of the cyclist between 2 and 3 seconds? Why is the graph not very realistic? Okay, first of all, 15 kilometers per hour. We can see that by looking at the graph. What is the motion of the cyclist between 2 and 3 seconds? It is stationary, again because their speed is 0. If there is no speed, you can't possibly be moving anywhere. The graph isn't very realistic because it doesn't show acceleration. It simply shows a specific speed, or an instantaneous speed, rather than an average speed. A stone falls off a cliff. What is the speed of the stone at 1 second? How fast is the rock going after half a second? And what can we calculate from the graph? First of all, at 1 second it's 10 meters per second. So at half a second it must be 5 meters per second. And obviously we can calculate acceleration because it's the change in speed over time. We can use the graph to determine the acceleration. A final one, the skateboarder rides a half pipe. What is happening to the speed of the skateboarder from 10 down to 0 meters per second? Why does the velocity become negative? And what does velocity mean? Okay, firstly, he is decelerating. Secondly, the velocity becomes negative because he is travelling backwards. What is velocity? It's speed with direction. Okay, we can now look at forces. I've been Mr. Chick, I hope this video has been helpful to you. Thank you for watching.